AZPICK, all rights reserved.
Hey guys, it's me Lunar, I'm back, and today we have our bi-weekly dev report for the game to go over in PUBG on console, and this week we're looking into GPU and how that affects frame rates in the game. There's no new info for this week's dev report about future updates, content, or when Vikendi will go to the live servers, which is a bit unfortunate, but to be honest we didn't really expect any new info this close to Christmas, but I will be keeping you guys posted as we get that info in the future. But for now we have another detailed dev report to go into. Let's jump into it then. If you find this video useful, a like is very much appreciated. So what is GPU time? GPU time, simply put, is the time the GPU, or the graphics processing unit, takes to calculate a single frame. The more GPU calculations required, the longer the GPU time will be. GPU times directly contribute towards the FPS, or frames per second, and you see those while playing, and increased GPU times can directly impact performance. Now, there are numerous factors that affect GPU time, including the time it takes to render all the different visual elements of the game you see on screen. And the GPU is a process that handles computer graphics. It draws millions of pixels on the screen each frame, multiple times per second, and the number of pixels contained on the screen is determined by the resolution used. The higher the resolution, the more pixels and more detail that can be shown on each frame, but also the more processing power will be required. So when comparing 4K resolution to the most commonly used 1080p resolution, 4K has 4 times as many pixels as 1080p. That means the amount of data GPU needs to process comparatively increases 4 times, which in turn increases the GPU time. And I hope that all made sense to you guys. What about dynamic resolution? And dynamic resolution options are currently being optimized in the game, but they will be available for the PS4 and Xbox One in the future. But how will that actually work in game? Well, dynamic resolution is a feature in which the resolution changes dynamically according to the number of GPU calculations required. And it changes the resolution from 1440p to 4K in real time, with a variable refresh rate. In circumstances when you're in a match and the GPU is under heavy processing load, the resolution will be lowered automatically temporarily in order to ensure stable performance. And you can see how this works in this graph. Please bear in mind that the graph is measuring GPU time in milliseconds, and this graph is not showing frames per second. So in this instance, lower is better. A 20% improvement in processing speed for GPU times is observed with dynamic resolution turned on. A lower GPU time means the GPU can process each frame more quickly, which leads to improved and more stable performance. So this graph shows how GPU will be improved when they introduce dynamic resolution options in the future. What about GPU instance culling? This has been enabled since 1.0 for Xbox One X and PS4 Pro, and they've made many improvements since its initial implementation to increase performance. They'll be making additional improvements to GPU instance culling in the future, including the next live server update, but we don't have an actual release date for that yet. The upcoming improvements to GPU instancing culling are still being optimized for the first gen PS4 as well as the first gen Xbox and S models, and those will be implemented at a later date. You can find many dense forests in Erangel, Sandhawk and Vikendi, and to achieve the best performance possible, trees with the same model are rendered using instancing. This reduces the processing cost of drawing a single tree, so the GPU can draw the forest shown in this image here, waiting for additional draw cells, the resource-intensive request for the GPU to perform its tasks, to be issued. Reducing the number of draw cells by instancing as many trees with the same model within the viewing distance as possible, the overall cost for drawing the trees is reduced, leading to improved performance. But what happens if, for example, you use an 8-scope? The level of detail plays a big part in achieving the desired performance, as objects are drawn in different quality levels depending on their distance from the player. In a normal non-scoping state, only the close trees with the first instances are drawn as LOD 0, the highest object detail, but when scoping in, all instances including the target trees seen through the scope are drawn as LOD 0, causing GPU time to increase, lowering performance by a significant amount. When you scope in, the viewing distance is extended so the distant trees can be viewed in higher detail, and in this image again you will see 3 to 7 trees through the scope, but the GPU will try to draw every instance that hits the view spectrum. Using instances in this case is a significant drawback because it will draw unnecessary trees, whereas if you didn't use instances, only 7 trees will be drawn. The object's LOD then is determined by proportionate size on screen, and the object's cull distance decides whether the object will be rendered at all based on distance from the player. With some upcoming optimizations to GPU instances culling, the goal is to increase performance both through non-rendered high level of detail objects, which aren't shown on screen, and developing a smarter process to determine which objects are processed when instancing and in which order. Since the GPU is aware of all object LODs, only the low LOD models will then be chosen to be instanced after examining all instances. Then the rendering process is performed in front to back order, and this is called select and process GPU instance culling. Again, we have another graph and it compares the GPU time and the GPU instance culling on and off in 4K resolution. Here we can see a more stable result and around a 30% improvement in GPU time with GPU instance culling on. Without GPU instance culling, you can see GPU times are longer and they do fluctuate more considerably. So guys, I hope this has helped you understand how GPU time works, how they plan to improve this using dynamic resolution, and how they also plan to improve GPU instance culling to again improve GPU times. But guys, that is about it for this one. If you want to see more PUBG, Red Dead, and other share game news, updates, and guides, make sure to subscribe. If you have any questions, leave them in the comments below, and don't forget to check out the links right here for more similar videos. Enjoy the rest of your day, guys, and I will see you all in the next one. Peace out.